OpenAI deployed GPT-5.5 codenamed Spud directly onto Nvidia's own infrastructure. This is not a demo or a waitlist feature. Over 10,000 Nvidia engineers are already using it as a live agentic coding assistant. The significant detail: this is the first time OpenAI has placed a frontier model inside a partner's stack, rather than routing traffic through its own API endpoints. That architecture choice matters more than the model name itself. The scale is noteworthy. This deployment is tied to a 10-gigawatt Nvidia systems commitment. That is infrastructure at grid scale, not a cloud credit. OpenAI's original Codex launched in 2021 as a code completion model derived from GPT-3. It powered GitHub Copilot through an API handoff. Your editor sent tokens to OpenAI's servers and received completions in return. Nvidia and OpenAI operated as vendor and customer. Nvidia sold GPUs, OpenAI purchased and trained on them. The new version of Codex, powered by GPT-5.5, operates as an agentic background agent. It does not simply complete lines of code, it takes multi-step actions inside a live codebase. This shift from autocomplete to autonomous agent forced a different deployment model. An agent that opens files, runs tests, and modifies build systems cannot route through a public API without exposing proprietary code to external servers. That exposure risk is what necessitated a new infrastructure approach. GPT-5.5, deployed on Nvidia's own stack, solves this problem. GPT-5.5, internally codenamed Spud, powers a next-generation version of Codex that operates as a background coding agent. It is not a chat interface or autocomplete bar. It is an autonomous system that takes sequences of actions across a codebase without human approval for each step. Over 10,000 internal Nvidia engineers have access to it, a single company rollout larger than most public betas OpenAI has released. The model runs on Nvidia's own infrastructure. Model weights and inference compute live inside Nvidia's network perimeter, not on OpenAI's API cluster. This satisfies enterprise security requirements that would block agentic tools from accessing live proprietary codebases. Connectivity operates through remote SSH connections to approved cloud virtual machines. In practice, Spud can open a shell on an authorized VM, navigate the file system, read source files, execute commands, and write changes back, all within Nvidia's approved cloud environment. No external data exposure is the explicit security guarantee this architecture provides. Nvidia is running the system for hardware debugging and software experimentation cycles. Hardware debugging at Nvidia's scale involves firmware, driver stacks, and hardware-software integration layers, not just web applications. Accelerating those cycles represents a different magnitude of productivity impact than speeding up boilerplate generation. This deployment is tied to a 10-gigawatt Nvidia systems commitment. That figure represents physical power capacity for compute infrastructure and indicates how seriously both companies view this as a long-term architectural commitment rather than a pilot project. The deployment architecture is now a competitive axis for enterprise AI, a significant shift from the standard playbook. Until recently, companies accessed hosted models through APIs with data processing agreements. This approach works for low-sensitivity tasks. It fails when an agent needs persistent access to proprietary hardware IP, unreleased chip designs, or firmware representing years of research investment. Nvidia's codebase is precisely that asset. GPT-5.5's on-premise deployment on Nvidia infrastructure sidesteps this problem by collapsing the trust boundary. The model does not call home. There is no API hop where a packet carrying Nvidia's source code transits OpenAI's network. The data never leaves the approved cloud VM environment. That is an architectural guarantee, not merely a contractual one. This sets a precedent for the broader enterprise market. If OpenAI can deploy GPT-5.5 directly inside Nvidia's stack tied to a 10-gigawatt infrastructure commitment, the next conversation with a defense contractor, a semiconductor firm, or a financial institution running sensitive workloads becomes a straightforward pitch. We can do the same for you. That is a different sales motion than selling API credits. The OpenAI-Nvidia relationship itself has shifted structurally. The prior dynamic, Nvidia as GPU vendor, OpenAI as GPU buyer, has become something closer to a co-deployment partnership. OpenAI's most capable agentic coding model is running inside Nvidia's infrastructure, helping Nvidia build better hardware. That creates a feedback loop with strategic implications for both. OpenAI gains direct signal on how its agent performs on real, complex engineering tasks at massive scale. Nvidia gains accelerated debugging and experimentation cycles on its own hardware pipeline. Both sides now have material stakes in the outcome, a relationship structure that a procurement arrangement does not create. Several open questions merit tracking. First, will GPT-5.5 Spud reach general availability, or does it remain a dedicated enterprise deployment? Current status is early access for over 10,000 Nvidia engineers, with no announced public release date. Second, the 10-gigawatt infrastructure commitment implies a long-term capital relationship between the two companies, but the terms have not been publicly detailed. The broader question the industry will watch is whether this on-premise agentic deployment model extends to other OpenAI enterprise partners, and at what point does GPT-5.5's token efficiency economics make that model commercially viable outside a flagship partnership like Nvidia. Token efficiency, the cost per action of an agentic system running thousands of multi-step sessions across 10,000 engineers, will determine whether this architecture scales or remains bespoke. That number has not been published. What is confirmed, GPT-5.5 is live inside Nvidia's infrastructure, running real hardware debugging workloads today. The next factual signal to watch is whether OpenAI announces a broader enterprise on-premise offering and whether the Nvidia deployment becomes the reference architecture for that program.